everyone, welcome back to my YouTube channel. Today we are going to learn about a topic from design and analysis of algorithms. Let us now understand what do we mean by algorithm. The definition of an algorithm is as follows: a clear path to a solution. At its core, an algorithm is simply a set of instructions that take in an input and produces an output, like a compass that helps you navigate through the problem space. Creativity within constraints. Despite being a rigid set of rules, implementing an algorithm often leaves ample room for creative problem solving and optimization, just like designing the perfect lighting setup. A folded masterpiece. Like origami, the process of designing algorithms is also about breaking down complex tasks into smaller ones, more manageable steps, and then folding them together into complete solutions. Here we are going to understand what are the properties of algorithms. Efficiency, accuracy, and readability are the three properties of algorithms. Efficiency. A better an algorithm is at minimizing resource usage, that are CPU cycles, memory, etc., the less expensive it is to run and maintain. Accuracy. An algorithm should always produce the correct output for all valid inputs, just like playing a game with darts and trying to hit the bullseye. Readability. A good algorithms are always easy to understand and are maintained by other developers, just like well-written lectures. Performance analysis, estimating space complexity and time complexity of algorithms. Performance analysis is essential for ensuring the efficiency of algorithms. In this presentation, we will explore how to estimate an algorithm's space and time complexities. Generally, there is always more than one way to solve a problem in computer science with different algorithms. Therefore, it is highly required to use a method to compare the solutions in order to judge which one is more optimal. The methods must be independent of machine and its configuration on which the algorithm is running on, shows a direct correlation with the number of inputs, can distinguish two algorithms clearly without ambiguity. There are two such methods used: time complexity and space complexity. What are space and time complexities? Space complexity: the amount of memory an algorithm requires to run. Time complexity: the amount of time an algorithm takes to run. Measuring the complexities helps us understand how efficient an algorithm is and how it will perform in different situations. The importance of time and space complexity. Good algorithm design is all about balancing two priorities: the time it takes for your code to run and the amount of memory it uses. By understanding the time and space complexity, you can write code that is efficient, fast, and scalable. Now we are going to learn how to measure time complexity. We can measure time complexity with big O notation. Now, what is big O notation? Definition of big O notation is as follows. Big O notation is used to describe the upper bound of an algorithm's time taken. Example: an algorithm takes 4n plus 2 steps, has a time complexity of O of n. Importance of time complexity and big O notation. Understanding big O notation makes it easier to compare and contrast different algorithms. Measuring space complexity, memory usage, and big O notation. Big O notation. Big O notation can also be used to describe the upper bound of the memory an algorithm will use. Memory usage, like time complexity, space complexity, can also be measured by looking at an algorithm's memory usage. An algorithm that uses an array of size n has a space complexity of O of n. Let us now understand time and space complexities with examples. Example of time and space complexities are as follows. Time complexity. A brute force solver for a maze can have an exponential time complexity. Space complexity. A program that uses recursive function call can have exponential space complexity. Importance of understanding performance analysis. Optimizing code, real-world applicability, problem-solving skills. Now let us study about optimizing code. By understanding an algorithm's performance, we can optimize code to be more efficient and faster. Real-world applicability. Performance analysis is essential in real-world scenario where time and space are limited resources. Problem-solving skills. Performance analysis is also critical for developing problem-solving skills as it provides a framework for analyzing and optimizing solutions. Conclusion. Understanding space and time complexities is crucial for optimizing code. Big O notation is a useful tool for describing an algorithm's performance. Performance analysis is important in real-world problem-solving scenarios.